All right, recording in progress. I'll give you all 5 minutes to do number one. All right, how my Zoom people doing? Y'all need more time? Put a Y if you need more time, and an L if you don't need more time.
Is there any way you could post the link in the email next time if it wasn't in it? I didn't see it.
Okay, I tried to be fancy with the flyer, but from now on, I'll post the links in the email.
Okay, thank you.
All right, so since I got a few L's in here, we're gonna go ahead and go over this. So if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? So what do y'all think when you see this? Y'all thinking limiting reagent, theoretical yield? Any of those come to mind? If the answer is no, go back to basic chem. I'm kidding. So when you see a question like this, always think like limiting reagent, theoretical yield. Those are always words that come to mind. So if it says how much sodium chloride can be formed, another way of them asking this question is the theoretical yield of sodium chloride. So another way of doing that is the theoretical yield. So if we were to do that, right, now we have to first find the limiting reagent in order to get our theoretical yield. So 15 grams of copper 2 chloride, CuCl2. Can anybody tell me the molar mass of copper 2 chloride? 134.45. 134.45 grams. Mole. And then, right, we need to get sodium chloride. So let's get everything into moles of sodium chloride. So for every 1 mole of copper 2 chloride, there's 2 moles of sodium chloride. And I got that from this balanced chemical equation. Because if there's nothing there, you just put a 1, and then there's a 2 right here. So now we do the same thing. 20 grams sodium nitrate. And then anybody want to tell me the molar mass for that? $147. Wait, you said 147 for sodium nitrate? Sure. All right, there's an 84, so somebody got 84. Which 48 plus 14, that's 62. 62 plus like 23. Yeah, it should be 84, 85. So yeah, let's go with 85. 85 grams, 1 mole. And then right for sodium nitrate, it's a 1-to-1 ratio. So for every 2 moles sodium nitrate, there's 2 moles, again, sodium chloride. So 2 and 2, that reduces 1 and 1. So 1-to-1 ratio. Then if we bust out our fancy calculator device, just somewhere in my backpack. All right, so if we do 15 divided by 134.45 times 2, we'll get 0.223 moles of NaCl. And then we'll get 20 divided by 85. And then 2 over 2 is 1 over 1, so this is 0.235. All right. So with that in place, what is our limiting reagent in this case? Copper chloride, that's right. Yeah, copper 2 chloride, because you have less moles of NaCl here than you have moles there. So 0.223 is less than 0.235. That's why this would be a limiting reagent. Then, right, you need to figure out your theoretical yield from this. So you do 0.223 moles of NaCl. And then, right, you just get to grams by multiplying by the molar mass. So 1 mole is, let's see, 23 plus 35.453. It's approximately 58.45 grams. That's molar mass. And then you set that equal, so 0.223. We multiply that out, then we get a theoretical yield of 13. What would be the sig figs here? Y'all help me out with the sig figs? 2 sig figs, exactly. So 13 decimal point grams of NaCl. The decimal point just indicates that there's digits after the decimal, so it's not just 13, like exactly 13. So yeah, that is how you do number 1A. Any questions about that? People in the class and people on Zoom? All right, we got 1 thumbs up. So I guess y'all do indeed understand this. Okay, what is a limiting reagent? Well, we sort of already answered this. It is copper 2 chloride. That, of course, is our limiting reagent because we solve everything out, and then we see that the moles here is less than the moles formed from sodium nitrate. So that's why that is our limiting reagent. All right. How many grams of copper 2 nitrate is formed? How would y'all go about solving this? Something really easy you can do. You could do that. So if we go above here again, so 0.223 moles of NaCl, if you do it that way, and then you can just convert that to moles of copper 2 nitrate. So 2 moles of NaCl means 1 mole of copper 2 nitrate. And then if we solve that out, it's just 0.223 divided by 2. And what we'll get is 0.1115 moles copper 2 nitrate. And then from there, right, it's just multiplying by our molar mass to get the grams. So 1 mole. And then to get our grams, molar mass of copper is 63.5. So 63.546 plus our nitrogen, which is 14.007, plus 3 oxygens. So that's 16 almost, or wait, CuNO32. So it's 2 nitrogens, 63.546 plus 28 for the nitrogens. And then there's 6 oxygens. So that's 16 times 6, which is 96. This is, again, I'm just doing a rough estimate of the molar masses, because honestly, I can't be bothered to write out every single decimal. And honestly, it would save time in like a test setting. So then you multiply this 0.1115, and then your answer here will be 20.91 grams of copper 2 nitrate. Right.
187.56.
Yeah, 187.56. I'm told I have great handwriting. 187.56. Let's get that a bit quick. All right. Is that a bit more legible? All right. Then you get 20.91 grams of copper 2 nitrate. Any questions? Speak now or forever hold your peace, as some might say. No? Okay. So if 11.3 grams of sodium chloride are actually formed from this reaction, what is the percent yield? All right, this one, we already found the theoretical yield, so this will be pretty easy. What is our formula for percent yield? Somebody on Zoom. So what's our formula here? Percent yield. All right, we got our experimental divided by theoretical times 100, or actual over theoretical times 100, same thing. So actual over theoretical times 100. So we're going to do 11.3, which is our actual yield, divided by our theoretical yield, which we solved in the problem earlier, which is 13 approximately. The decimal point was like 13.0, so it'd be around the same thing. So actual 11.3 divided by theoretical 13 times 100, we will get 86.92% as our percent yield for this reaction. All right, questions about any of that? Zoom people and room people? Wow, I rhyme. That's crazy. Does this all make sense? All the stoichiometry? All right, silence basically means yes in some languages, so I'm gonna go with that. All right, number 2, I'm gonna give you all about 5 minutes to do this problem. And man like Dylan should probably pull up when that's on. And like the,
Long walk from the building on the other side of campus. Oh, are you doing it? Nice.
we're on question 2.
Are you giving them time to work on it?
Oh, yeah.
Oh,
5
yeah?
minutes.
Oh, yeah. How long has it been? Do you know how where the closest restroom is? Because cold weather made me want to pee.
Who's this?
Oh wait, are we on me? Oh my,
You gotta give me more clickbait times. So we're good.
TA needs to pee, question mark. Oh wait, we're still on mute. Okay. So you don't know where the closest restroom is?
Walk around till you find one.
Okay. You said about 3 more minutes, right?
Yeah. All right, after Dylan comes back, we'll reconvene on this problem. I should just go over it. All right, what do y'all think, you people? Should I go over the problem? Did y'all have enough time to complete it? Right. All right, let's go ahead and go over it. All right. 25 grams of lead-2 nitrate and 15 grams sodium iodide. If I start with it, oh wow, I get to do the reaction. I'm special. How many grams of sodium nitrate can be formed? So this, right, is again a question like the one previously, where we're trying to look at our theoretical yield, and then from there go from like theoretical yield, limiting reagent. We'll go through all the same steps. So let's do that again. Let's go down that rabbit hole. So 25 grams of PbNO3(2). And then, right, what is the molar mass of lead? I don't know, some number. The molar mass of lead is 207 grams per mole. So we're going to do 207 plus 28 plus 96 again, because that's 16 times 6, 331 grams for every 1 mole. All right, now what's our mole ratio? How many moles of sodium nitrate do we have per lead-2 nitrate? 1 to 2, 2 to 1, same thing. It's just how you write it. So 1 mole is 2 moles of sodium nitrate. And then, right, let's do this again. 15 grams sodium iodide. And then iodine's like 127, so it's 127 plus 33. By the way, it helps to memorize molar masses, so that's 160. 160 grams for every 1 mole. Oh, for real? 23, is it not 127?
That's 126.9, but sodium is 22.
127 plus 23. Oh, it's 150, okay. This is why it also helps to use a calculator, not do mental math. So, oh yeah, that's a 5, not a sigma. So 150 grams per every 1 mole. And then, right, you got to look at your mole ratios. So for every 2 moles sodium iodide, you have 2 moles of sodium nitrate, which is the same thing as a 1 to 1. So however many moles of sodium iodide sodium iodide, that's how many moles of sodium nitrate you have. All right, then if you grab your calculator, solve this out, divided by 331 times 2, you'll get 0.15 moles of this. And then if you do 15 divided by 150, that should be 0.1. Yeah, it's 0.1 exactly. 0.1 moles. What's your limiting reagent? Yeah, sodium iodide. So this one is your limiting reagent. Are we done? Is it over? Can the pain stop? No, we gotta do our theoretical yield. So now that we found our limiting reagent, we can go 0.1 moles of sodium iodide. And then we can say, okay, how many grams of sodium nitrate can be formed? Or this should be sodium nitrate, my bad. 0.1 moles of sodium nitrate. And then from the grams, we can just use our molar mass. So this is 23 for sodium, plus 14 for nitrogen. So Na, N, and then 3 oxygen, so that's 48. So 23 plus 14 plus 48. Solve it out, we get 85 grams. So 1 mole has 85 grams of NaNO3. So if we solve this out, 85 times 0.1 should just be 8.5 because the same thing is divided by 10. So 8.5 grams of sodium nitrate is our theoretical yield. Are we done now?
No.
Yeah, part A, are we finished? Why not? For part A, are we done with the work for part A? All right, yeah, the painstaking process is done. Our theoretical yield is found, 8.5 grams of sodium nitrate. All right, and then man like Dylan, I keep talking UK roadman slang, can do the limiting reagent.
So. Did we figure out which one is the limiting reagent from this previous problem? And what? It was sodium iodide. Look at that. Perfect. How many grams of lead to iodide form? So to figure out how many grams of lead to iodide form, we need to use which reactant again? Why? Yeah, so we have to use sodium iodide again because it's the limiting reagent, right? So wait, why wouldn't part A have 3 sig figs? Well, but actually both of them have 3 sig figs, right? You count the 0 and the decimal point.
Oh.
I don't know, Rich. Why would the answer not have 3 sig figs?
Why would the answer not have 3 sig? Maybe possible.
Let's see.
But
85 times 0.1 would be 8.50 with sig figs. So it changes the number quite a lot.
it changes the significance of the number, doesn't actually change the number itself.
0.00 with the difference.
Yep.
No, you're right though. For this first exam, we care about sig figs. Anything after this, we're not going to care about sig figs. So like after this exam, 2 numbers past the decimal point is perfectly fine, okay? Unless you have a teacher that cares about sig figs in Gen Chem 2, or if you have to take analytical chemistry, you don't need to care about sig figs, okay? But yeah, good point. So we should have 3 sig figs. Remember that next time. Okay, so we should start with our sodium iodide, right? Because that's our limiting reagent. So we had 15 grams of sodium iodide. We use the molar mass in the next step to get moles of sodium iodide. And someone on Zoom, tell me why we want to get moles of sodium iodide. Any of my Zoomies? Asked to unmute. I'm just kidding. Okay, anyone? No. What about people in class? Why? What?
Oh wait, why we're changing?
Yeah, why do we want moles of,
Moles of lead to lead.
right? And we go because we want to go to moles of another compound, or I guess in this case, we want to go to moles of a product. And the only way to do that is to use the balanced chemical equation, right? And you need to use the molar ratios. So we found that for every 2 moles of sodium iodide, 1 mole of lead 2 iodide is formed. All right, so it'll be a 2-to-1 ratio. So 2 moles of sodium iodide produces 1 mole of lead 2 iodide. Okay, and now what should we do here? Molar mass. Do y'all know the molar mass of lead 2 iodide? 461. That's a big. Any decimal points there or just 461?
I did it, like, added it all.
461, that's crazy. And for 1 mole of PBI2. Any questions so far? If we punch this into a calculator, do y'all have an answer? Yeah. This calculator stinks.
Hey. I'm bad now, for the stop. That's pretty good if you know how to use it.
Oh, I know how to use it. Times 460. Sorry, I have to like put so much force into the keys to make them register. So 23.05 grams of PBI2. That's it. We're done, right? So just as someone mentioned in class and mentioned earlier, we should have 3 sig figs. Exactly. So 23.1 grams would be our answer. All right. And if 6 grams of sodium nitrate are actually formed in the reaction described in problem 2, what is the percent yield of this reaction? What's the equation for percent yield? Someone on Zoom? Not you. Someone on Zoom? No, we just know y'all know it. And I just want to interact with our Zoomies too. Actual over theoretical times 100. Perfect. So, and we're talking about sodium nitrate. Oops, sodium nitrate. So we're going to use this one right here. So our actual was said to be 6 grams. Our theoretical we said was, what do you say? 8.50. Remember 3 sig figs from earlier. And times 100. What did we get here? 8.5. Yeah, sounds about right to me. 70.58%. How many sig figs here? Which one is it? 7? You said, yeah, it would be 70 with no decimal point. Because if you add a decimal point, that makes it 2 sig figs, right? Exactly. How do y'all feel about that? Everyone on Zoom and all the students that are in the class.
I wish I had a 7% yield. It's not nice.
I'm not being mean, but can you run through the problem again? I can't read the writing.
A part of it's mine.
That's crazy. Okay. Yeah, I'll go ahead and run through it. So if someone starts with 25 grams of lead-2 nitrate and 15 grams of sodium iodide, how many grams of sodium nitrate can be formed? So what is the key thing to think about whenever you're given the information about 2 reactants? People on Zoom. We were given information about sodium iodide and lead-2 nitrate. Someone on Zoom? Convert from mass to moles and find limiting reactant. So yes, it's the last part that Ewan said, is that we need to figure out the limiting reactant, right? Because we have grams for both reactants, therefore one of them must be the limiting reactant. So she said, or they said to do the, is convert grams to moles, and we did that using, so 25 grams of lead-2 nitrate. And we know that 1 mole of lead-2 nitrate has a molar mass of 331 grams. And then we use the formula or the molecular, what are they called? Molar ratios from the balanced chemical equation to figure out to convert from moles of lead-2 nitrate to moles of sodium nitrate, our product, right? We got that from here. So for every 1 mole of lead-2 nitrate, 2 moles of sodium nitrate are produced, and then you should get, I believe that's a 0.15, if I had to guess what that number was. Rich, is this a 5?
Yeah, it's 0.15.
Okay, yeah, so this is point.
That's not a sigma. It's a 5.
Oh. Okay. Does that make sense so far? And you're literally going to just repeat that process with the second one. So 15 grams of sodium iodide, we convert to moles of sodium iodide using the molar mass, which is 150. And then we use the molar ratios found in the balanced chemical equation to get 2 moles of sodium nitrate. And doing that, we got 0.1 moles. Which one produced the least amount? That's going to be 0.15 versus 0.1. So clearly 0.1 is lower, right? So that's going to be, that means sodium nitrate was our limiting reactant. And this is going to also be our theoretical yield. So now we have, this is our theoretical yield of sodium nitrate, or, well, sodium iodide was the limiting reactant, right? Yeah, but this is the theoretical yield of sodium nitrate. And no, you're good, you're good. So sodium nitrate, we just use the molar mass of sodium nitrate to convert from moles of sodium nitrate to grams of sodium nitrate. And then we get our answer. Bang. So that's answering the question of how many grams of sodium nitrate can be formed. The next question was, what is the limiting reagent? And we said earlier that if the amount of sodium nitrate that we had produced the least amount of product, then we know that sodium iodide was our limiting reagent. So sodium iodide is the limiting reagent. And if this was a multiple choice test and it says which one is their limiting reagent, you should be able to see that if they gave you all an answer choice of A, B, C, or D, you should be able to eliminate these two, right? Because these are products, they can't be your reagents. So if you didn't know how to get to this answer, you would have a 50-50 shot between the two here. Any questions on that? That was it's a hefty problem. It's a lot of steps. On the test, you wouldn't see it in this layout. It may say, what is the percent yield? Here's the information. What is the percent yield if 5 grams are formed? So it requires you to do all this stuff, but it's not asking you for, this is not going to be your answer. It's going to be, this would be your answer. Yeah. Are there any questions on Zoom or in our very full classroom? No. Okay. All right, let's go ahead and do number 3. We'll give you about 5 minutes to do that one. And we'll work through it afterwards. Rich, do you think it's an exo or endothermic reaction?
Seems pretty excellent.
I know why.
Because you're forming the bonds.
Yeah. But to form bonds, you release or you gain in what you have. Release.
Please, correct.
Is this ionic?
That's it.
I would say so too. We don't know the answer. We're just hypothesizing. Let's see. A delta H of formation is always positive number, right?
Yeah.
So this is similar to delta H of reaction or delta H of formation.
Not really, because there's not a 1 mole product.
Well, yeah, but sign would still be the same. It should be more. When you're, for people on Zoom, just go ahead and like raise your hand or put it in the chat when you're done. Don't put any answers, so that way if everyone's done now, we can just start on it, but.
W, if you need more time, I'll let you know. They already used the word. Hmm? Wait,
Well, why should he care what happened to the one?
is that?
No, I'm just kidding. Yeah, switching up the letters every time. All right,
How many sessions are there?
every week. It's Monday, Thursday, Friday, yeah,
Tomorrow, 2:30, be there.
or B square. Or just, being square just means getting a bad grade on the exam.
Or it could be a triangle for those 4 sessions, triangle in this.
I like the frost circles. Okay, everyone done on Zoom? Yes, no. You want to come do this one, Rich?
Pretty nice. Why cut that off?
Oh, yeah.
You're pretty high.
Yep. All right, let's see if I can actually make this one legible. Let's challenge myself. All right. Chemist burns 160 grams of aluminum and excess air to produce aluminum oxide. In the experiment, she produces 260 grams of solid aluminum oxide. The balanced chemical equation is the following. Determine the theoretical yield. Okay. Step 1, make it legible. So we're going to do this. 160 grams of aluminum. And what's the aluminum? What's the molar mass of aluminum again? 27 grams per mole?
What is it, Rich?
Should be 26.985 if I remember correctly. But looking at our periodic table, it's 26.982, 0.003 off. So I don't care. I'll just say 27 grams for every 1 mole.
Oh.
Always round your molar mass to the nearest integer. It helps. Unless you're asked for like sig figs and like do the calculations, I guess.
Where
Yeah.
actually those little decimals may matter.
But in the lecture, it doesn't matter. So, all right, we need to determine our theoretical yield. We only have 1 product, so that makes our lives easier. So for every 4 moles of aluminum, we have 2 moles of aluminum oxide. So if we solve this out right here, we do 160 divided by 27 times 2 divided by 4, and we get 2.96 moles of aluminum oxide. Is this legible so far? Y'all read this?
Very good.
That
Nice.
actually looks good.
All right. So now we do the same thing for our oxygen. Psych, no, we don't. Because we're not given an amount of oxygen. Because it says excess air, right? Excess air means that oxygen automatically isn't our limiting reactant. Aluminum by default, they told us, is our limiting reactant. So I'll just write that out right here. Limiting reactant. Okay, so we do 2.96 moles of that. Now we need to convert to grams. So 1 mole, there's 27 grams as before, so it's 54. Then 54 plus 48. So our molar mass is approximately 102 grams. So if we solve this out, times 2.96, we will get a gram amount of a large number, 301.0 0.92. I'm gonna say hold off on the sig figs for now, because in our percent yield, we're gonna come back stronger with the sig figs. But if you were to say do your sig figs, then there would be 4 right here and then 4 over here. So the total sig figs here would be 4 in total. So what you can say 301.92, this would be 302.0. 302.0.
Why not 301.9?
That could also be the case. 301.9. I just wanted to round. 301.9 grams of aluminum oxide. All right, so that's our theoretical yield. Now for our percent yield, as some person on Zoom has said multiple times at this point, is our actual divided by theoretical. Let me make this more legible. So ACT over theoretical times 100. We're told in our problem that it produces 260 grams of solid aluminum oxide. So 260 grams are actual yield over 301.9, which is our theoretical yield, grams, just to prove it cancels out. So if we do that, we do 260 divided by 301.9. Solving that out, we get 0.8612 times that by 100, and we get 86.12%. We're done here, right? That's it. 86%. That's our sig figs, because there's 2 sig figs right here.
Oh my. See that?
Oh, 260.0. That's why you don't ignore stuff and always do your sig figs. 260.0. So as you can see, 4 sig figs here, 4 sig figs here. So our final answer should have 4 sig figs. In which case, the correct answer is 86.12% with sig figs and all included. Hey, sig figs.
Any questions? You got this one in the bag for the test?
No problem. You can do it one eye open, backwards, like holding the pencil by your feet.
Should I do it just during the?
Oh, you should.
Well,
Yeah.
that's accurate, right?
Yeah, I'll give you 10 extra points. No.
I'll about stand up and shake.
Let's go ahead and let them do the last one. Oh, we got 2 more. Let's do number 4. In the meantime, we'll give you all some time to do that, and I'm gonna test Rich on see if he memorized the periodic table yet.
All right.
I told him at the beginning of our winter break that he needed to memorize the periodic table.
Do you have the whole, wait, do you all have the whole?
No, it just makes life easier.
Yeah, let's see if he has his money up.
Not
No,
even
not-
like just for doing like these types of problems. Like I just said nitrogen was 14 grams per mole. That stuff like was all off the top of my head.
What?
Yeah.
14.0074, but it's kind
My bad. Wait.
Hey, what is the element that has an atomic number of 79?
79.
Yeah.
What is this one? Tungsten 74, premium, osmium, iridium, platinum, gold, obviously.
Obviously it's gold, right? What about 43?
43. That should be scandium somewhere around there. Krypton's 36. Rubidium, strontium. Wait, 36 or 39?
No, I said 43.
Yttrium, zirconium. Technetium.
Yeah, that's the one. Oh my god.
Machine.
All right, what about 72?
72 happening.
What 107?
107.
Yeah,
Boreum.
yep, that's the one. What about 62?
62. Quite the talk.
Hey, y'all should be doing this problem, by the way. Okay.
I'm following along here.
Oh, on Mario? That's him.
That is samarium. Mhm. Okay, well, I guess you memorized. Hey, Rich, you think at the end of this, maybe we can show them a YouTube video?
Maybe not the end of this. Okay, before final exams, I'll show you that video.
What video?
You'll see.
That sounds like a threat.
It's not a threat.
Is it a promise?
It's a
Yeah.
promise. If you get a perfect score on any of these exams, we'll show it to you. Pretty- It's like 66.
I mean, which is pretty decent. We're trying to get like an 89.
Yeah, exactly. But it's so hard to get a higher average when only y'all, a very few amount of students come to these. So bring your friends, guys. Maybe you can have a study date here. Will be, collaboration on these problems. Okay. Anyways, number 4. Make sure you edit that one out. Okay,
I don't edit everything. How should you know this?
that's
I
right.
think they're gonna hear about your break.
Yeah, they definitely will.
Yeah, that's more clickbait comments for me.
Okay.
If you saw our last video, it said TA shower.
For in the reaction of zinc with hydrochloric acid, zinc chloride was actually formed. Okay, that's interesting. Although the theoretical yield was 143 grams, what was the percent yield? Okay, so clearly it only gives us information about which thing. Oh, well, it gives us, yeah, right? So it's actual percent yield is equal to actual over theoretical times 100. Which one's our percent yield? I mean, our actual yield
Actual is 1.1.
and theoretical was 143. Okay, so
98.
this guy's one step ahead. 143 times 100 is what? 93 point what?
98.0.
That's pretty good.
What a percent yield, 98%. That's that your TA raises doubts if you get that percent yield type in.
Yeah, like your TA in lab will be like,
Oh,
Mine were like 20%, 30% most of the time, Gen Chem 1. Okay, 1 lab, different story, but yeah.
okay, one lab, let's just say wasn't his cup of tea.
Yep.
He broke glass every lab.
Not every lab, it was 1 lab. No.
TA breaks glass every OChem lab.
That's a good clickbait, right?
Yeah.
there. Hey, number 5 now. If there's no questions on 4, we'll do 5. Ready to try out your legible handwriting?
Oh, yeah.
Oh, I was talking to Faith and she was like, why don't we do my decisions?
Even I pull up.
Oh, she was saying how a couple of Yoshimoto kids come.
Ones that sit on front row.
Oh, honors kids?
Yep.
Excellent.
I mean, I pull up too, on occasion.
I bet. I wonder why.
Our reason for biology.
12.5 grams of copper are reacted with an excess of chlorine gas. That helps because now we know that we know what the limiting reactant is. We don't need to find it.
What is our limiting reactant out of curiosity? Yep, that's our limiting reactant. Then 25.4 grams copper 2 chloride are obtained in the experiment. Calculate the theoretical and percent yields. Are y'all good? Do you need any more time or no?
People on Zoom, y'all need any more time?
your TA is gonna raise a few more questions.
TA is gonna be scratching their head.
TA is gonna be scratching her head. I think you're gonna Academic dishonesty, we didn't sign that agreement, so,
There's no way it's above 100%.
well, it's not about fun.
Okay.
That's rich type percent yields.
No, that's certain other people's, and then they make up data.
Don't make up data in your Gen 1 lab.
TA makes up data. All right, that's the official title. TA makes up data. Okay. 12.5 grams of copper are reacted with an excess of chlorine gas. As we've discussed before, copper is already our limiting reagent, so that saves us some trouble. So 12.5 grams of copper. And then what was the molar mass again? 63.546.
Oh, yeah.
Oh, yeah, 63.546. So 63.546 grams for every 1 mole. All right, so that's done. And then the nice thing about this is it's a 1-to-1 ratio. So however many moles of copper we have is also the amount of moles of copper 2 chloride, which is nice that way. So 12.5 divided by 63.546. You solve it out, you'll get 0.1967 moles of copper 2 chloride. And then all we have to do is just convert this bad boy into grams. So to do that, we got to use our molar mass. 134.446, I am told, is molar mass. And I'll trust that. So grams. And then if we solve this out, we'll get 0.1967 times 134.446. And our theoretical yield, copper 2 chloride, is 26.45 grams. So we're done with one part of the question. This is our DO yield. All right, how do we get to our percent yield? Yeah, so our percent yield, let me use a different color. Percent yield is going to be actual over theoretical. So for that, we have 25.4, and then we're going to divide that by 26.45. So 25.4 divided by 26.5. Solve that out. We'll get 0.9603. 0.03. So, and then we'll times this by 100 to get 96.03%. Is that our final answer? Exactly, sig figs. There's 3 here, and there's 3 right here. So your final answer should have 3 sig figs. So 96.0%. All right. Any parting questions? Anything last minute? Do you want us to run through any of the problems again? All right, I will take that as y'all are all good. So that about concludes today's session. Like, subscribe, comment, all that YouTube fun stuff that helps the algorithm apparently. And yeah, if y'all have no further questions, I will see you all tomorrow at 2:30 SEB. Be there or on Zoom, either or. All right. Y'all have a great rest of your day. Both of y'all gonna be square?
I have to say, I have a